Okay, in this video we're going to talk about a concept of continuity. This is sort of a beginner's definition of continuity. When we take calculus, if you're taking calculus, don't use this as your definition of continuity. It's a very just intuitive sort of beginner definition of continuity. So before we actually talk about what it means to be continuous, we're going to talk about what it means to not be continuous. So we're going to talk about something called a discontinuity. A discontinuity means that the function, that there's a break or a hole in the graph of the function. So there's sort of three common ways this happens. So you could have a hole in the function. So let's say you've got some curve in the xy plane representing a function. So the xy plane. The function's going along nice and normal, and then for whatever reason, there's just a hole, an open circle at the value for x equals a. And in this case, this function is not continuous because there's a hole at a. So we'd say there's a discontinuity at x equals a. We'd call this a point discontinuity. Okay, so that's one way you could have a discontinuous function. Another way, and this one you've probably seen before, is what we call a infinite discontinuity, and really this just means a asymptote. So a vertical asymptote. Horizontal asymptotes don't cause discontinuities. So let's say this is the point A. Got a vertical asymptote here, the value x equals a. So something like this. So the function is not continuous there. So it's not continuous again at x equals a. And we call that a infinite discontinuity. And the third one is what we'll call a jump discontinuity. So what that one looks like, so again we'll make a, x equals a, our discontinuous, our point of discontinuity. So you've got a function going along, whatever, and then at a, we stop, and then we jump down here, and then we start going along again, just on a different curve, or a different part of the curve. So it's one function even though it looks like two different ones. It's one function because there's different values of x that each is covering. So this is f of x. Okay, so these are different types of discontinuities. So these are functions that are not continuous. A function is continuous, and this will seem like a fairly obvious definition, if there are no points of discontinuity. Over its domain. So that's our definition of continuity. And again, it's just a sort of informal, general guideline of what it means to be continuous. When we get to calculus, we'll come up with a much more technical definition of continuity. So, a function like this, a good way to think about continuity is if you could draw the function without lifting your pen off the paper, then that function is continuous, right? These ones up here, if I was drawing this, I'd have to take my pen off the paper to get to the second part. Same with the jump, right? I have to stop, remove my pen from the paper, and keep going. Or here, there's a hole. So that's another way to think about a continuous function. If you could draw it without removing your pen from the paper, then it would be continuous. And it kind of makes sense why you call that a continuous function. One thing that I just like to point out now, and sometimes this is an issue, our definition says that a function is continuous if there are no points of discontinuity over its domain. Well, let's look at this one with the asymptote A. Um, we said A is where the discontinuity happens, right? Because that's where you'd have to take your pen off the paper to get to the next part. Well, here's the problem. A is not in the domain of this function, right? The function does not exist at the asymptote. So you might be saying, well, then isn't it continuous over its whole domain? I mean, its domain is everything here, and it's continuous there. I could draw this. And then this is not in its domain anymore. And then here, this is part of its domain. So it's continuous here, and that's where its domain is. It's not continuous at A, but A is not even its domain, so that's okay. That's true. This one's sort of continuous over its domain, but it's not continuous over the whole set of real numbers, which is usually what we think of when we talk about continuity. Although it's a bit of an issue, and to be 100% obvious sometimes, or to be 100% truthful, sometimes textbooks, and our textbook does a bad job of it, don't really stress like the difference between make this point. So you'll hear people talk about this being continuous over its domain, but then not continuous over all real numbers. But for what we'll say is, if it's not continuous over all its real numbers, then it's not continuous, right? So even though you take this point out of the domain, we're still going to say that's not continuous.